Hello, and welcome to the first lesson out of a series of lessons that will help you learn Python programming. In this lesson, we're just going to be going over some of the very basics, such as printing a sentence or storing some data. But as we go into future lessons, we're going to be learning some more advanced concepts. Now, that being said, let's get started. Now, if you want to do some Python programming, one thing that's really important is having a compiler. Now, there's two options which you can choose from, one being an IDE, for which I'd recommend PyCharm, the community edition, links down below in the description, or an online compiler, like you can find online. Now, an IDE would require an installation process. A video for that would also be in the description. But if you're too lazy to do that, you can just use an online compiler for now. But I would really suggest an IDE if you want to go further with this, because it can save projects and it is generally more efficient. And yeah, anyways, links in the description. Now let's get started. Now, the first thing we're going to be learning about is the print statement, which basically is the statement that whatever you give it, it'll print it out in the terminal. Okay, so we're going to be using the print command to print out the line hello world. So how do we do that? So first we type in the print command right here, and inside these brackets we enter what we want to print. Now keep this in mind, whenever you're printing something you have to enclose it in quotes. So if you want to print hello world, you put in quotes hello world. Now, when we explore variables, you'll know exactly why we're supposed to put quotation marks, but for now, just remember that you have to. And now, if we click run right here, we get hello world. Now, I encourage you to try this on your own. And by the way, if you are wondering what this is, well, that's basically just where the file is that's being run. And this is basically just to say that the process finished, without any errors. If it did have an error, let's say we didn't put the quotations in, and we run this and we get exit code 1. So basically exit code 0 means it ran without any bugs, and exit code 1 means it did have bugs somewhere. And in this case, because we didn't put the brackets, I mean the quotations. And now let's talk. I'll be talking about variables, which basically is how you'll be storing your data. Now, what exactly is a variable? So think of it like this. A variable is like a label box that stores information. So the label box will have a label, which is the name, and the value, which basically is what's inside the box. Now, when I say variables, you probably think back to your algebra class, where a variable is basically a letter that has a number that represents it, right? So like x equals 5 or y equals 10. Now, we can have something similar here where you can have a variable x storing the value 5. But it's not just numbers it can store, it can also store words like Jack. And the variable doesn't have to be a single letter, it can be anything. It could be something like name or age, and you can really just store anything in it. Like, as you can see here, we're storing the name Jack under the variable name and 22 under the variable age. So we can store stuff like that. Now, let's go over the rules that you need to follow when creating a variable name. So, variable names can only contain the letters, like capital or lowercase, the numbers, or the underscore symbol. You can't have like special characters like the ampersand symbol or the plus symbol or whatever. And variable names cannot have spaces. Now, that's an important rule. Variables should be like one word or like one string of characters. You can't have a space in between them. And it cannot start with a number. And of course, keep this in mind that they're case sensitive. So, like these two variables, like they don't mean the same thing. So you have to keep that in mind when referring to them. Now let's go over some illegal and legal variable names. Now over here, the variable name starts with a number. It starts with 1, so that's illegal. So it has to start with a letter or an underscore. Now over here, it's using an illegal character. It's using an ampersand. That's not allowed. So instead, you can do this. And over here, the variable name uses space, which is not allowed. So you can just remove the space and do this. Now, with all these rules, especially the rule about no spaces, it can make some of the longer variable names look cluttered. So, of course, the most important rule here is to make your variable names meaningful. Like, if you're putting the age of something, make your variable age. Don't make it a or worse x. When you're going back to your code, or if somebody else is looking at your code, they'll have uh, a lot of trouble finding out what you meant. Now, with the no spaces rule, variables with multiple words may look a little messy. And to make them more readable, there are some conventions you can follow, and these are the two main ones. So we've got camel case, which basically means the first word is completely lowercase, and in the following words they are capitalized. So, for example, with number of days, we have number, the n being lowercase, and the next O and D being uppercase. Now, another thing you can do is snake case, which means like every word is completely lowercase, but to separate the words, you have an underscore. Now, you can choose in both of these anything you want. I personally prefer using camel case, but it's your choice. Now, let's talk about data types. So, what exactly are data types? Well, a data type is basically something that tells the computer what kind of data you're storing in a variable. Now, as we've seen, we can store many types of data. Like we can store a word or a number, but how does the computer know that we're storing a word or a number? Like, how does the computer know that 4 is a number or hello world is a word? I mean, not exactly a word, but two words, but you get the point. So, there are four basic data types. So first is int, which basically means it stores an integer value. Now, if you remember what an integer is from school, basically means any like whole number, positive or negative, without any decimal part, including zero, by the way. That's also an integer. So examples include 1, 25, -4, those kind of numbers. Now, a float basically is an integer, but it has the decimal part as well. So basically a rational number. And examples are 3.14, -2.9, and so on. Now, a string is basically something that stores a string of characters. Now, it doesn't have to be one word, it can be multiple words too, it can have space, it can have anything, but it's basically like text. So, like hi or hello world or just a date. Now, a boolean or a bool basically is a binary value, like it's either true or false. It can store one of those two values. So, it can be true or it can be false, like it can't be anything else. Now, if you want to find the data type of a variable that we already have, there's this command in Python called type, which basically just tells the type of the variable. Now, let's just say we have a variable called num with a number in it, let's say 40. So now let's see the type of the number. And of course, if we want to see it, we got to print this. So we can print the type of the number. So let's see what we have here. We get this, meaning it's an integer, an int. Now let's say we put a string instead. Let's say we put hello world. That is str. If you want to put a decimal number, like -2.04, that's a float. And if you want to put true or false, let's say true. We get bool. Now remember how I told you need to put quotations to write a string? Now let me just show you why that's important. Now let's say you don't want true as a boolean value, but rather like as a string. You want the string boolean. Let's see what happens if we enclose the same true in quotation. Do we still get bool? No, we get string. Now let's try this with a number. 4.5. That should come as float, right? No. So basically, what these do is it tells that the data type is a string. I mean, for anything else, it can be inferred, right? If we just put 10, I mean, obviously that can't be a boolean because, well, that is not true or false. And it cannot be a float because there's no decimal. So it has to be an integer unless it's a string. Basically, if it has quotations, it is a string, and if it doesn't, it doesn't have, it's not a string. As simple as that. Now, let's move on to arithmetic operators, which is basically just how you'll be doing math in Python. So we have 7 basic arithmetic operators. So for addition and subtraction, we just have the classic plus and minus as symbols. For multiplication, instead of using the cross, because it can be easily confused as x, we use an asterisk. For division, we just use a slash. And for power, like normally we use a number and a small number on top of it, and or whatever. Well, in Python, what we do is we put 2 asterisks. Like for example, we have 2 followed by 2 asterisks. 3 basically means 2 to the power of 3, so 8 in this case. Now here we have two ones that might be new for you, but it will be useful, uh, for certain things. Now we have floor division, which basically just takes the quotient. So it's basically just division, but it only takes the whole number part. So for example, 14 floor division 3 basically means 4. So because if you do 14 divided by 3, you get 4.66666 or whatever, or 4 remainder 2. So you just take out the remainder and you get 4. Now the remainder, also called modulus, is basically just you take that remainder part. Again, when you divide 14 divided by 3, you get 4 remainder 2. So the 4 part is quotient or floor division, and the 2 part is the remainder, which is the modulus. Now, when it comes to adding or subtracting things or whatever, now you have to keep data types in mind very much. I mean, obviously, you can't. I mean, how are you supposed to add hello world and 3.5, right? I mean, that doesn't make much sense. So, when using arithmetic operators, some data types that are incomparable, let's say adding an integer to a string, let's say adding 4 to high, that would result in an error. And to circumvent this issue, if you really want to say if you want to put it as a string, then you need to change the data type. Now, what do I mean by converting the data type, and where would it be useful to add a string and an integer? Now, let's just say you have a program where you have a movie, let's say Despicable Me, and you have a part, which means, like, let's say the movie has multiple sequels, Despicable Me does. So let's say we have part 3, and we want to print out, the movie plus the part, right? So let's see what we have here, and whoops, we cannot have that. Why? Because this is a string and this is an integer. Now there are 2 ways to solve this. You can just convert this to a string. I mean, you can just put it that way and you get, oh, whoops, I need to add a bit of a space here. Right? Need to add a space here, and I need to add part. Yeah, there we go. Despicable Me with the space 3. Now, another way to do this, let's say you have a program where it's in the middle of a program and it needs to add some things to get that number. Well, then it would be, you can't just go in the middle of the code and change it. So what you can do for that is convert this data type. So there are some commands to converting the data type. So if we take str of a number, then it just stores that number as a string. Now let's say we have int, integer of a string of a number, then it just gets stored as an integer of that number as well. And obviously, this is only possible if it's actually possible to convert it to that. Now, let's say we have um, an integer of 50.9. I mean, that is not an integer, that is a float, so that won't work. So, if you want to try it, we have print, print int for 50.9. I mean, that just won't work. But if we put print int 50, which is an integer, then we have 50. Now, if you want to see this in action, you convert the part to a string. So we use str, And it works. We have Despicable Me 3. That's because, say we have part 3, and it says S part, which is the part of the string is str, right? So if we print the type of that, string, because it's converted to that. And the same thing can be applied if you in reverse, you know, iPod means integer part. Well, I forgot to change this name to iPod as well. Keep that in mind, as SPod doesn't exist anymore because I changed that one. As you can see here, we now have class int, so it is an integer. Now, let's move on to user inputs. All the codes that we've done so far are not exactly interactive. I mean, it's just using stuff from inside the code to just output it, but it's not really taking anything from the user. And if you know anything about applications, most of them depend on some kind of user input and not just printing something that is already written by the program. Now, how do you take a user input? Now, a user input can be taken using the command input. Pretty straightforward. And how it works is you type the input in the terminal, and this is taken by the computer, and it does whatever it wants with it. And unless specified, you have to keep this in mind, but unless it's specified, the user input is taken as a string. So if the input was intended to be another data type, it has to be converted as you take the input, right? So now, for example, if you're taking an integer input, you take the input and then you convert it to an integer. As you can see here, you take the input here and then you convert it using the int thing that you saw like 2 minutes ago. And it can be used if you take it as an integer. Now, let me show you why this is important. Now, let's say we have a simple program that we're trying to make where it takes a number and then doubles that number and prints that. So, for example, if it takes 4, it outputs 8. So, let's say we have an input. So, we have the number, we take it as the input, and then we print 2 times of the number. Now, will this work? Let's try 3 and 33. I mean, that's not right. 2 times 3 is 6, not 33. Now, the reason why this is happening is, as I said earlier, it's being taken as a string. Now, when you take 2 times the string 3, it takes string 3 because it's string 3. Now, if you literally join them together, you get 33, which is why this is coming. Now, how you can fix this is when I've taken the input, I convert it to an integer. Look at what I have here now. So I put 3, I get 6, as expected. Now, let's take what we've learned and do some practice programs. And don't worry, since this is the first lesson, they'll be really simple. Now, the first program is extremely simple. You just take a message from the user and just output the same thing. So basically talking Tom, but without the fancy interface and all that. Before I go ahead and show you the solution, I encourage you to pause the video and try this on your own. I'm assuming you had a go at it. If not, you can just go back and pause it. Or if you don't want to, that's fine as well. Now let's move on to the actual program. Now, of course, if you want to take the input from the user, you're going to have to use the input command. Now, we are probably just going to be taking stuff as strings. We don't need to convert them to integers or anything like that. So we don't need to put int or bool or whatever. Now, of course, we're going to store this input somewhere. So we're going to need a variable. So let's name this. We're going to name this the text. We're just going to take the input from it, and that's going to be the text that you're going to be outputting. Now, how are you going to output the stuff? I mean, you have to print it, right? So we use the print statement, and we need to output the text. So we're going to print the text. Now, notice that I'm not using quotes here, because if I use quotes here, let's see what happens. If I put hello world, I will not get hello world. Instead, I will get the text. Because again, these quotes tell that the text is a string and not the variable the text. It's string the text. So what we have to do is remove this, and this tells it that is the variable the text, and it's not actually a string. And this will actually work. Let's see. Hello world. It says hello world. As simple as that. Now let's move on to the second problem, which is just an adder. So what it does is it takes two numbers as input and the sum of them will be printed as output. So if you have 3 and 4, it'll output 7. Now again, I encourage you to try this on your own. Don't worry, this is also a really simple program. Just pause the video and try it on your own. Now I'm assuming you had to go at it. So now let's continue into the problem. Now of course, we're going to need to create two variables to store the two numbers. So we have num1 and num2. Now the first number and the second. Of course, for each of them, we need to take an input. And of course, you print the sum. You take num1 plus num2, right? And we have 3 plus 4. Oh, 34. That's not right. But again, if you remember, we're going to have to convert this to an integer because when you take an input, no matter what you put in there, the program's going to think you put a string. So you convert both of these to ints. Now you can do it here. You can also, if you want, do it in the print statement itself. So you can do int num1 plus int num2. Now, of course, you can do either, and this will still work. This will work, and the old solution will also work here. So if you are going to be using these as integers in general, I'd suggest you change it here in general because in actual coding you'd probably use the same variables two times. So let's say we have here printing the sum, and then let's say in the next line you're printing the product. If you have these converted, then you don't have to worry about this twice. You have 3, 4, you get 7 here, 12 here. But if you're converting it in the actual print statement, well, you're gonna have to do that twice. You're gonna have to put int here and another int here, and then you're gonna have to do this again for the second print statement. You're gonna put an int here and an int here. It's just more tedious to do that. So I'd strongly suggest if you're just taking the thing as input, just put the integer right there. Now, in the description, and this will be true for every lesson, there'll be some worksheets in the description, and there are 4 problems which you can solve on your own. And in the next lesson, I'm going to be briefly going over the solutions before starting. This will help you challenge yourself based on the concepts you just learned. And it's just good practice because the problems we just did are really basic, but these will require, they're also pretty easy, but they need a little more thinking. So good luck. And thank you for watching. And, I'll be seeing you in the next video. Bye.